All right, so in section 3, we're going to still be talking about how to transform these functions that we've been talking about. But instead of looking at the graphs, we're just going to be looking at their equations and then writing out like the rules that they're telling us. So which direction is it going and how do we actually write that out in the equation so that if we needed to graph it, we could. But we're not going to spend any time in this section doing graphing. We're just going to look at the equations and look at what they're asking you to do, and then use those rules to help us write the new equation. So we're going to start first by going over translations. So similar to section 1, translations, remember, is like a slide. So that's when you're pushing the graph to the left, to the right, up or down, or any combination of those. So we had two different types of translations. We have the vertical shift and we have horizontal shift. So vertical shift would be moving it left, right, and horizontal would be going up or down. So when we look at our rules for that, the vertical shift, you either add or subtract a number from the end of the expression. So again, most of the time when we think about this, that's moving it up or down. So when we saw our parent functions the other day, when we were in section 2 and you guys had to graph the new function, you looked at the equation and you would look for either like a plus or a minus number at the end. And that would tell you if it's going up or if it's going down. Plus meant that it goes up, minus means that it goes down. And then that number just tells you how much is it going up or how much is it going down. So if we have the equation 3x plus 2, and they want us to translate this equation up 4 more units, what I would do to write the new one is rewrite that 3x plus 2 down. And if I'm going up 4, that means that plus 2 needs to get added to that 4 because I'm going 4 more up. So 4 is going to stay positive. So right underneath the 2, I'm just going to put plus 4 because that's going to be the up 4 units that they're talking about. And then if I just drop down the 3x and I take 2 plus 4, I'm going to get plus 6. So my new function would be that 3x plus 6. So a lot of times you'll see them write the new function as like g of x equals 3x plus 6. And they change it from f of x to g of x just to show the reader that they have switched the function. It's not the exact same. Because we could graph both of those if we wanted to. So for the second one, it says to vertically translate it down 3 units. So again, if I start with the original 3x plus 2, how do you guys think I would write it if I'm going down 3 instead? Good, minus 3. And again, that's just going to go underneath that 2. So I'm still going to have 3x. Now we have 2 minus 3, so that's going to be negative 1. So we would write 3x minus 1. Again, I could say g of x equals 3x minus 1. Okay, so those would be your vertical shifts. So that would be moving it up or down, because that's affecting your y-axis. Now, horizontal shift, that's when we moved it left or right. And so when we were looking at our parent functions, I kind of said the big difference here is that that number is going to be put inside of parentheses, or it's going to be included underneath the square root sign. So on what we were just looking at, those last two problems had one of the numbers inside the parenthesis and one of them underneath the square root sign. And we talked about how it's right or left. And this is also when you have to think backwards a little bit as far as do you add or do you subtract. So if you're moving to the left, you have to add the number. And if you're moving to the right, you subtract the number. And you only do that to the x term. So whatever your x would be, that's what you're subtracting your number from. So if there's a number on the outside, we won't worry about that until the end. Okay, so I'm going to show you how this looks, because where we're putting the number changes a little bit here. We still have that same function. We're going to use that 3x plus 2 again. This one wants to do a horizontal translation 3 units to the left. Okay, so if I come back up here, my rule says add to x to go left. So in the function, in parentheses, If you think about, if I rewrite that as like 3 times x in parentheses plus 2, what I'm going to do is take the 3, and then inside the parentheses, I'm going to do x plus that 3. Because adding the number moves it to the left, and I'm going 3 to the left, so that's why I'm doing plus 3. Then we still have that plus 2 on the outside. So what I need to do to simplify this one is first distribute. Take 3 times x and 3 times 3. So then we're going to have 3x plus 9, and then we still have plus 2. So to finish up the simplifying, because you can combine the 9 and the 2, our function is going to say 3x plus 11. So if I needed to check my work for some reason, like I just wanted to make sure I did it right, what I could actually do is graph the original function, that 3x plus 2. Then I could graph this new one, that 3x plus 11, and every point should shift 3 spots to the left. Like I should be able to go from my original graph and count 3 to the left, and I should find a new point on my new graph. So that would be a way that you could check it. That does involve graphing though, which I said we're not going to be doing that today. So if you wanted to check it, you'd have to just do that extra step on your own. But you can, and that would be a really good way to just make sure that you did it right. So why don't you guys try to do number 2? They want you to do a horizontal shift 5 units to the right. Okay, so for this one, because I'm going 5 units to the right, the rule up here when you go to the right is that you have to subtract from x. So I'm going to end up having to subtract the 5 in this problem. Now you could write it, kind of start it out the same way that I did up here. If you need to, kind of already put x in its own little parentheses so that you know where the minus 5 has to go, you can do that. So what you should have written is 3 and then times the x minus 5 and then plus 2. So the big difference here is instead of doing plus 3, I did minus 5 because I'm going the opposite direction and I'm moving a different amount. Now I distribute again. So that's going to end up with 3x minus 15 and then plus 2. Then I can take negative 15 and the positive 2 and I can combine those. So final answer should have been 3x minus 13. Alright, if we turn the page here, our next type of transformation that we're going to talk about is reflections. So when we talked about reflections in section 1, when we had like points that we were looking at, we just had to change the sign of one of our numbers. So if it was the x-axis, you changed the y. If it was the y-axis that we were reflecting over, we changed the x-axis or the x-coordinate. When you're looking at a function and you want to reflect across the x-axis, you have to change all the signs. So that means that you change the sign of every single item that's in your equation. So most of these equations are going to be written in that slope-intercept form, mx plus b. So you're going to change the sign of the slope with the x, and you're going to change the sign of the y-intercept. Now, if you're reflecting across the y-axis, you only change the sign of the x. So I'll show you how they look a little bit different here. So for this first one, we're still going to use that same function that you've been dealing with the last couple of problems. That 3x plus 2 is what we're working with. Number one wants us to reflect across the x-axis. X-axis rule says we change all the signs. So that 3x plus 2, I change the sign of 3x to negative 3x, and I change the sign of plus 2 to minus 2. So negative 3x minus 2 is my new function. For the second one, they want me to only reflect it across the y-axis, so the rule for this one is to change the sign of only the x. So again, if it helps, put that 3 and then put x in parentheses next to it, plus 2. So you only change the sign of the x term. So you're going to draw like a negative in that parenthesis now next to the x, because that's the x term that we're changing. And we still are going to have plus 2. So we don't do anything to that plus 2. If you distribute here, so if you just end up multiplying those, you're going to end up with negative 3x plus 2. You don't have to necessarily put the x in parentheses. If you can just see that you got to change the sign of that first term, just change the sign, but just make sure that you leave the b, the number that's attached, alone. Don't do anything to that. So reflections aren't too bad. If it's the x-axis, everything changes sign. If it's the y-axis, just the slope term, that mx term, will change signs. All right, let's take a look at stretches and compressions. So this was when we had to multiply factors. So when we talked about this in section 1, we went over, like, if you have to do a horizontal or a vertical stretch. Like a horizontal stretch, you multiply your x coordinates by the factor. A vertical stretch, you multiply the y coordinates by your factor. So when you're looking at the function, if you're doing a vertical stretch or compression, the vertical would be affecting the y coordinate. So that's usually going to make the graph really tall. You multiply the entire expression by the factor that you're compressing or stretching it by. So if I have a vertical stretch of 2, and I have still that function 3x plus 2, to find my new function, I'm going to take my factor, which is the number 2 here, times the entire expression, 3x plus 2. So I kind of think about putting that as like a number on the outside of like brackets or parentheses, and then we use our distributive property. So 2 times 3x, 2 times 2. So this would be 6x plus 4. So why don't you guys try number 2? Do a vertical compression of 1/3. So to set this up, we should have 1/3 out front, like I put my 2 out front for the first problem. And we're going to take that times the 3x plus 2. So again, use your distributive property. 1/3 times 3x you think about 1/3 times 3, it's going to become just a 1. Because the 3's are going to be able to reduce each other out to 1's. So you're just going to be left with an x for that first term. Then when I take 1/3 times 2, I'm going to leave it as a fraction. So I'm just going to write plus 2/3. And I'm okay if you leave fractions like that. Especially when we're writing equations, it's probably better to have fractions. Because like we've talked in the past, graphing decimals is not easy to do. So for the horizontal stretch or compression, instead of multiplying the entire expression by our factor, we only multiply the x, but we also have to multiply by the reciprocal. Do you guys remember what a reciprocal is? Yeah, it takes the number as a fraction and it flips it. So if your fraction was 2/5, to flip that over, it would be 5/2. Now, if it's a whole number, like 3, number 3 as a fraction would be 3/1. And then when you reciprocal that, you would get 1/3. Okay, so you have to take the factor that they're giving you, think of it as a fraction, flip that number upside down so it becomes the reciprocal, and then take that times only the x, so not the entire equation. For this first one, the horizontal stretch is 3. So 3, if I think about the reciprocal, would be 3/1. I flip it upside down, so the reciprocal is going to be 1/3. So that's the factor that we're going to be using here. So I'm going to, again, if it's helpful to you guys, put x in parentheses for the ones that you only have to affect the x by, so that you can kind of isolate that term and deal with that first before you do any other simplifying with the equation. So we're going to take 3, and then for my x, it's going to be 1/3 times x. And then we still have plus 2 on the outside. So when we have 3 times the 1/3 times x, you know, the 1/3 times x is just going to stick those together because we can't turn that into like a new number. So we're still going to end up distributing here. And we saw this earlier on that last problem. 3 times 1/3 is just going to be 1. So you're going to end up with just x. And then there's going to be that plus 2 left. So our new function would just be x plus 2. So why don't you guys try number 2? Do a horizontal compression of a half. So if you guys start, what's the reciprocal of a half? Good, 2. So that's the factor that we're going to be multiplying times the x only. So again, if you split it into the parentheses to kind of help you out, just put parentheses around the x. So to get started here, we're only taking 2 times x, and then plus 2. So then what we did is we distribute, we take 3 times that 2x in there. What's 3 times 2x? Good, 6x, and then plus 2.